Welcome. Today we will learn how to take care of missing data in data science process. Here, first of all, I will talk about why it matters to take care of missing data. Because in real world data sets, in so many columns, we have missing values. There are n number of reasons behind this because of manual entry errors, because of sensor failures, because of data corruption, data failures. So if we fit our data set with these missing values to our machine learning model, then it will lead to a poor performance of our model and it will give biased results and it will have bad impact on our output results. So to avoid this, we have to handle this missing values in our columns, because if we put the garbage in, then we will get garbage out. Now we will learn all these techniques depending on what type of data it is. If any row has more missing values, then what to do with it. If any column is numerical column, then what to do with it. If it is categorical column, or if it is ordinal time series data, if it is numerical but linear data. So for different types of columns, we use different methods to impute missing data. Now going ahead, I will show you all these options to handle missing data in Jupyter Notebook demo. So I'm going to Jupyter Notebook now. So here in Notebook, we will first import our dataset and libraries. Then we will visualize missing data patterns. After that, we will see in which case we can drop the column or not. Then we will talk about numerical columns. Then there are two methods using SimpleImputer and fillna to impute numerical columns and categorical columns. Then we will talk about time series data, and then we will talk about interpolation of ordinal data. So we will go through all these options of imputing missing data and we will learn how to handle this carefully. So going ahead, in next cell, here in this cell I have imported libraries required for us like pandas, numpy, matplotlib, seaborn and missingno. I have used read underscore csv to import our dataset. Now I took a copy of that our original dataset because we will keep on imputing and changing our dataset. So to track that copy, I have taken separate copy of that in df and I am printing here shape of our dataset. Here you can see our dataset has 100 rows and 7 columns, and I am here showing you this dataset. It has 7 columns. Out of this, last column, which is performance score, it is dependent column. So it has some dataset from some firm. This dataset is having columns joining time of employee, then track of employee count, then marital status of that employee, then work shift in which that employee works, then experience of that employee, then salary of that employee, and performance score of annually or quarterly. So here, if you see, we want to check first, is there any missing value in these columns? So if we use df.isNull.sum, it tells us the number of missing values in those particular columns. So these are columns, this one, and these are number of missing values in those columns. So all these missing values in each column, we have to do something so that we will get better results when we fit our dataset into machine learning model. Now, after this, I run this d types to know what type of our columns are. So joining time is categorical column, object means categorical column, int or float means it is numerical column. So employee count till date is numerical. Similarly, other marital status, work shift are categorical, and rest of the columns are numerical. So I have summarized our data set details in this table. You can see first is in column I have mentioned all the columns. Then in data type I have mentioned types of the columns, then missing values and semantic type. Here if you can see in semantic type, there are some details about our column. Like joining time is having particular date of joining that employee, so it is like time series data. If you see here, for employee count till date, it is like a count of employee which are joining to that firm, so it is like incremental data. So employee count till date is linear, but it is ordinal and it is incremental also, like linear smooth incrementation. In marital status, it is categorical data. Work shift is also categorical data, like morning, evening, night shift. Then experience is numerical data, but here if you can see, the values are either 1, 2, 3, 4, 5. So this is numerical with discrete values, and salary is having numerical values. We are not considering performance score into account because that is dependent variable. Now here we will learn how to handle these different types of columns, how to handle missing values in these. So first of all, we will visualize the missing patterns in these columns. To visualize missing patterns, we have two options. We can use missingno library and seaborn library. I have imported missingno library on in first code cell. Here you can see this one, and I'm using this also, seaborn also. With these two libraries, I'm importing some functions, and we will visualize first the missing patterns. So if I use missingnos, I have imported missingno library as msno, and I'm using matrix function from that missingno, and I'm running this code cell msno.matrix in bracket data frame and plt.show. It shows us some plot in which we can see all these are columns, this one, 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 and this white pattern is missing value in that particular column. So you can see here visually that marital status column are having more missing values because white patterns are more. Last performance score has no any missing value, but that is dependent variable. Worksheet has some missing values. All other columns are having missing values. This pattern we can see visually. Similarly, we can use seaborn's heat map in next figure like this sns.heatmap, and we are checking is there any null values in those columns, and we are plotting here. In this plot you can see these vertical columns are mentioned and it shows the missing cells in those patterns. So till now we have visualized the missing patterns in our dataset. Now from here we will start how to handle these missing values. So our first check will be if that missing value column is having more missing values like more than 50%, more than 70% or 80%. So if that column having that very less data and that data is also not that much useful for our end results, then considering dropping that column itself is a good idea. So to decide this, first of all we will check percentage of missing values in each column. So we will calculate missing percentage by this statement df.isNull.mean into 100. So this will print missing percentage here. Here I am just sorting those values. Now this I have set this 50% threshold. So for time being I have set 50%. You can decide on your own because this can be critical to decide this threshold value for different data sets. So I'm checking which column are having what percentage of missing values here, and I'm segregating out the columns which are having more than threshold value. So and I'm storing that columns in calls to drop. I'm printing here missing percentage by column first. So you can see this is missing percentage. So marital status has 58%, which crosses our threshold of 50%. Joining time and all rest of the columns are having 10%, so not more than 50%. So our column to drop is marital status. So before deciding whether to drop this marital status column, we have to check that whether this column has whatever the values are these values important and which impacts our end results or dependent variable. We have to think twice and then we can decide that considering dropping that column itself. So don't immediately rush to drop that column, because if we drop that whole column it will lose some values from our data set. Now once we finalized to drop that column, we can use dot drop function and mention that column names inside bracket and we can drop that column. So I used here df dot drop function to drop marital status column because it doesn't impact performance score in the firm. So now our new data shape, I have changed this dataset df dataset itself because I have storing in the df only. So our dimension of new dataset is 6, are having 6 columns and 100 rows. Now till now we have learnt here whether to drop that column or not depending on percentage of missing values and the importance of that column. Now we will learn about numerical columns. So how to impute missing values in these numerical columns. So to decide the option of imputing missing values, we have to understand first how the data in that column is distributed. Is it normally distributed or is it skewed distributed? Here I am just checking the dataset columns, particularly numerical columns, and I am checking distribution of those columns. So here I am first of all, this performance score is target column like dependent variable. So I am not considering that performance score here. Similarly, this employee count till date is having incremental values. So I am not considering these two columns because that is ordinal data. So if you can see here in our dataset summary, I had mentioned that it looks first that employee count till date, experience and salary are numerical columns, but employee count till date are having ordinal data and it is linear also, so we are not considering that as a exactly numerical column for imputing because we are using some different method to impute for employee count till date column. So for time being we will consider experience and salary column as numerical columns. So we will check the distribution of the data in that column, particularly about these two numerical columns, experience and salary, and then we will decide how to impute these missing values in these two columns. So here I am segregating out our numerical columns first here in this statement, like select d types, include number, and I am dropping these two columns. Now here I am just checking that missing values are present in those columns. Otherwise it's of no use to impute if there are no any missing value. Now I am checking skewness first. So in skewness I am applying dots here skew from seaborn SciPy library, this one, and checking skewness of that column. Here I am splitting that skewness depending on the value 0.5. If it is greater than 0.5 it is skewed, if it is less than 0.5 we are considering that as normal. So I stored skewed numerical columns in numeric underscore skewed, and I stored numerical normally distributed column as numeric underscore normal, and I'm just printing here, and we can see skewed numerical column to impute is salary column. and normally distributed column is experience column. We can visualize these two columns and verify that salary is skewed distributed column and experience as normally distributed. So I am using seaborn and matplotlib.pyplot library to plot histogram. This is histplot to check distribution of these two columns. So if you see here, this first plot is of salary and second plot is for experience. So this is the plotted image for these two. If you can see here, this salary column is skewed. This is right skewed actually, and below experience column is normally distributed. So we verified that salary column is skewed distributed and experience column is normally distributed. So the thumb rule is, for skewed distribution we will use median. We will calculate median of that column and then we will fill those missing values with median value of that column values. And for normally distributed column we will use mean value of rest of the values present in that column and we will fill that missing values in that particular normally distributed column. So in our case salary is skewed distributed, so we will use median to impute salary column and mean to impute experience column. So after plotting these distributions, now in this step I will impute these missing values with two different strategies. First is median strategy and another one is mean strategy, depending on skewness of those or depending on distribution of those columns. So here this median imputer, this one is used for skewed distributed column, that was salary, and mean imputer, this one, which is this actually. So we used this mean imputer to impute for numerical normally distributed columns. So earlier our experience and salary column were having missing values. You can see here. Initially I had run this. Experience column had 10 missing values and salary has 5 missing values. Once we impute using simple imputer, we are using simple imputer here from sklearn. This will use strategy as median and mean and impute that column. So you can see here our experience and salary columns missing values are filled either with median or mean of rest of the values in the particular columns. Here we learned using simple imputer from Scikit-Learn with mean and median to impute numerical columns. Now what about categorical columns? Categorical columns we can use mode, that is mostly occurred value in that column, to impute missing value in that categorical column. So we can use same simple imputer. If you can see here in this, first of all I am segregating out categorical columns present in our data set and I am dropping joining time because that is time series data. So in categorical columns only work shift is there, and in work shift, if you can see, it is day shift, night shift, evening shift. So most of the employees which are working in day shift, that's why the missing values in these columns are filled with the most occurred value, because while simple imputing I am using strategy as most frequent, that is mode value of that column. So it will get filled with day shift because the day shift is having more values in that column, work shift column. So after imputing that categorical column work shift, I am again checking the number of missing values in our data set, and it comes as work shift column got filled with this imputed values, that missing values got filled with imputed values. So till now we learned these numerical columns to fill with mean and median using simple imputer. We learned work shift column, that is categorical column, with simple imputer taking strategy as mode. Similarly, instead of simple imputer, we can use fillna function from pandas library using same statistical methods, mean, median, mode, for numerical and categorical columns. So to show you use of fillna, I am taking, because we have already imputed these numerical and categorical columns, to show we have used a simple imputer till now. There is one more method other than simple imputer is fillna. So fillna works with either mean, median or mode, similar like simple imputer. So first of all, I am taking our original data set, dropping that column which is marital status, which was having more than 50% values, and I'm just printing here number of missing values in our data set. So this was our data set. We had imputed with simple imputer. Now we are learning to impute missing values using fillna. So we will impute this salary, experience, work shift using fillna. So here this is very simple, that we know already by distribution, by checking distribution, that salary is skewed and experience has normal distributed column. That's why for salary we will use median of that column. For experience we will use mean of that column, and as work shift is categorical column, we will use mode, that is most occurred value, to impute in that column. So here with fillna, if I run this code cell, it will automatically fill missing values in these three columns, and once we check again the number of missing values, we can see here the salary, experience and work shift missing values are filled with mean, median and mode. So till now we learnt use of simple imputer with mean, median, mode, use of fillna with mean, median, mode. Now I am showing you what to do with date or time series data, and what to do with incremental data, because we can't use mean, median, mode on this joining time and employee count. The reason is joining time is categorical column and it has time series data. So we can use different option to impute this time series data. So there are two terms, forward fill and backward fill. The forward fill method fills any missing value in that particular column by copying previous row's value present. That is forward fill. And backward fill is in that particular column. Backward fill works as it copies the data value from next row of that particular column, next row of that column. So why we need to use both forward fill and backward fill? Because if any column is having initial and last values, in first row and last row missing values, then if we run forward fill will keep on filling missing values, but it will not fill first row value, because first row it don't have any previous row to fill first row. Similarly, if we run only backward fill, then in the case of column having last value as missing value, then it will not fill last row. So if we use both of these one after the another, then it will, suppose in our case we will run forward fill first, and then here if you see here I am running this forward fill first. What it will do, it will check each row one by one from row 1, and if any missing value is there, it will copy previous row's missing value and it will fill that missing value. But in our data set, if missing value is present in first row itself, so to take care of that, I am running this backward fill also. This will, after finishing with forward fill till last row, it will keep on checking till first row, and it will fill first row with second row of that value using backward fill. So with this forward fill and backward fill, we can fill missing values in time series data. So you have to remember this. Now after filling time series using fillna, how to use this fillna is we are taking that particular column with fillna and we are using method as forward fill, and in place true means it is directly changing values in data frame only. We need not put separately to df, it automatically changes the values in df itself. Similarly, backward fill, we will use bfill as a method and we will fill our missing values in time series data. After doing this, I am checking number of missing values in our data set, and you can see that joining time values, missing values were 10 initially, and after using forward fill and backward fill, we got filled all these missing values in joining time. Now last is employee count till date. This employee count till date is a count of employees joining in that firm. So it is incrementing like 1, 2, 3, 4, 5 by 1. It is incrementing by 1. So if any missing value is present in that column, we can fill with that middle or that missing value using some different method, and that method is interpolation. So for interpolation there are some criteria when to use interpolation and when not. So if our column values are numeric and changes smoothly like linear values like 1, 2, 3, 4, it is incrementing linearly, then we can use interpolation. If this data is ordinal, then we can use interpolation. When to avoid this interpolation? If the column is having categorical data, then we should not use interpolation because we want to linear data only, and it should be ordered, it should not be unordered, it should be ordered. So in our case, employee count till date is numerical column, which is ordinal column also, and which is linear column also, because these values are getting incremented one by one. So in this example, for a small example, before using interpolation on our data set, I'm showing you how it changes. So here if you see 1, 2, 3 and this NaN values are missing, then it replaces missing values using incremental values. So don't think this experience as our experience column. So this is just example, small example of use of interpolation. Now we will consider applying interpolation on our employee count till date column. So we checked that our column is numerical column. Then we check that it is having smooth trend in our column. It is not categorical data. So it is not noisy data or irregular spaced data or unordered data. We have checked all the things. Now after checking all the things, we decided that this is linear ordinal data and we can use interpolation method to impute missing values in this column. So to do this, I used this column and then used interpolate function. Method is linear, and after running this command I am storing it back in that column. After this I am checking again the missing values in our data set, and you can see all this employee count till date missing values got imputed. So till now we have finished the imputation methods. Now we will, there are some tips to do this. Do not impute before splitting dataset into train and test set. In our case we had dropped dependent variable, so do not impute before splitting. Next tip is imputation should be part of your machine learning pipeline. Then third tip is for date time, you can convert into year, month and week, day, and use this forward fill and backward fill to impute this data. This helps our model to learn better without leaking noise. Okay, now we have finished learning this imputation of missing values. Now I will ask you some small questions. You can press pause and answer these questions in comment section. First is, why is median preferred over mean for skewed data? Next is, what does most frequent strategy do in simple imputer? Third is, why should the imputer be fit only on training data? You can answer this. So this is a summary. So first of all, we learned how to check missing values in our data set using isNull and .sum. df.isNull.sum, which shows missing values in our data set. After this, we used missingno and seaborn library, missingno's matrix and seaborn's heat map to find missing patterns in our data set visually. After visual inspection, we started proceeding to impute the missing values in our data set. So first step is to check whether that column are having more than 50% or particular that threshold like 70%, 80%, and if that feature is not that important, then dropping that column itself is fine. That depends on intuition of your data set. So before dropping, you have to take care that that column, that particular feature is not that important, so you can proceed dropping that. After this, we learned SimpleImputer from sklearn using mean, median and mode. Mean and median for numerical values and mode for categorical values. So mean for normal distribution, median for skewed distribution with SimpleImputer. We learned fillna also, just like SimpleImputer, with this same statistical methods. So for numerical column and categorical columns, there are two methods. One is SimpleImputer and other is fillna. We learnt all this. After this, we moved further and imputed ordered time series data using backward fill and forward fill. We have to use both. Then in the end, we learnt how to handle numerical linear data using interpolation. That's it. Thank you.